Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun, and in today's video, I'll be talking about how do you automate a credit risk model. Now, a credit risk model is widely used, especially in the banking sector. But to demonstrate how automation of a credit risk model works, what I'll do is I'll open up the data set that I'll be working on. This is the source file that I have. As you can see here, I've got 6 variables. The first variable is the credit rating of the customer. Historically, there have been customers. We have recorded their demographic details like what is their age, income level, number of credit cards, education, car loans, and whether he has been a bad credit risk or a good credit risk. If a customer has defaulted on the payment, he is regarded as bad. And if a person has been paying every month, we have regarded him as good. You can see here, the first person, he's been a bad credit risk. His age is 36 years. Income is medium. Number of credit cards is 5 or more. Education level is college. And the number of car loans is more than 2. Initially, you're seeing only a few bad credit risk. But when I scroll down, you can see a lot of customers who belong to the good credit risk category as well. Now, there are more than 2,400 records in this data set, which means it's a good sign. I have got a healthy sample size. Let us investigate some of the variable levels that are present in each of these categorical variables. Let's look at income. There are 3 groups: high income, low income, and medium income. Let's look at the next variable, credit cards. There are 2 categories here. Either a customer can have 5 or more credit cards, or the second option is he can have less than 5 credit cards. Education level. There are 2 groups. One is that a customer has completed his high school. The second category here is that he has completed college. And the last variable that we have is car loans. That is, either a customer has more than 2 car loans, or he has 0 or 1 car loans. So using these 5 variables, namely age, income, credit cards, education, car loans, can I predict credit rating of a customer? To do this, I will be using IBM Modeler. As you all know, IBM Modeler is based on drag and drop technology. All that you need to do is, you see some of these options, you just need to drag and drop each of these nodes into the stream canvas and create a workflow. Once you're able to create a workflow, you will be able to build a model. The first thing that I need to do is I need to load the file into IBM Modeler. The question is, how do I load a file into IBM Modeler? To load the file, first of all, I need to close the source file. If the file is not closed, many times IBM may struggle to load the file. So make sure that the source file is not open. Then to import a file, you can see a palette which is called as source palette. You have to click on the source palette. It gives you a lot of icons. You can import a SAS file or an Excel file. Since the source file is a CSV file, that is comma separated values, I will click on the var file. I need to double click on this. Once I double click, the node appears in the stream canvas. What do I do at this stage? I need to double click on the var file. It is asking me to specify the path of the file. I can click on the browse option to specify the path of the file. It is taking me to one of the folders where tree_credit file is located. I can click on this particular file and then choose open. What do you see here? You see the first row contains the column headings like credit rating, age, income, so on and so forth. From the second row onwards, you have the actual data. You can specify different delimiters. I will click the default option of comma. because the source file, as you can see here, is separated by a comma. Let me click on OK. What this does is this loads the file. If you want to see a preview of the file, you can just double click and choose this option, preview, and it displays the top 10 records in the data set. So this is how I can load the file. The next thing that I need to do is click on the type node. How do I access the type node in IBM Modeler? To access the type node, you can see here there is an option which is called as field options. Once you click on the field options, all the nodes that are related to field level operations are displayed here. And the second node is what is called as the type node. Now you may ask me as to why do I need a type node? Type node allows you to access the variables and customize the variable properties. Let me double click on the type node. A new dialog box opens up. Here you can see all the variable properties are given, like what is the measurement level. Right now it says read because I've not instantiated the values. If there are any missing cases, that will be highlighted. Let me choose read values. What I'm able to see is a high level summary of the data set that I have. For each variable, for example, credit rating, there are two values, namely good and bad. Age, it has a lot of values because it's a scale variable. You can see here 20 point something, 63 point something. These are all customers' age. Similarly, income, there are three groups here: credit cards, education, and car loans. I will not disturb any of these. I'll simply say apply and then click on OK. So I have loaded the file. I have controlled the properties of the variables in my source file. What is the next step? The third step is to display all the variables in a spreadsheet-like format. How do you display the contents of the file in a spreadsheet-like format? Very simple. All that you need to do is click on the output palette. The very first option here is table. You can click on the table. You can see here there's an arrow which is pointing from the type node to the table node. You can execute this by pressing Ctrl E. You can see the entire file is displayed. As I scroll down, you can see all the records have been captured. So this is how you can import a file and display the contents of the file. The main purpose of this video is to demonstrate how you can automate the machine learning models. Now, even before I show you that particular option, let me get a high-level perspective by building a popular model which is called as C 5.0. It is widely used, especially for classification problems. How can I access this particular node? As you can see here, there's an option called as modeling. The moment I click on modeling, you can see a wide variety of options that IBM Modeler displays. I can choose the option classification because the source data has a variable which is called as credit rating. There are two categories here: good credit risk and bad credit risk. So this is a classification problem. You can choose any of these options, a tree-based method or a classification and a regression tree. I will choose the option C 5.0. When I bring the cursor on top of C 5.0, you can see here IBM Modeler describes what this node is all about. It helps us build a decision tree. Let me click on a C 5.0. I'll have to establish a connection between the type node and the modeling node. So right click and choose the connect node. Then you can establish a connection between the type node and the C 5.0 modeling node. IBM Modeler displays a message saying no targets. Because there is no target variable specified, IBM modeler is not able to construct this model. So let me open up type node. The very first variable, when you look at the last column, that is role, it is specified as input. You can click on the drop down menu and change the role to target, because this is the dependent variable. I want to identify the profile of bad credit risks based on the demographic details. The rest of the variables can be input. The word input here refers to independent variables, and the word target refers to dependent variable. Once I have done this, I'll just choose apply and OK. Now you can see here the message has changed to credit rating. Now IBM modeler, that is C5.0 algorithm, understands that I'm trying to evaluate the characteristics of high credit risk customers. Let me right click on this and choose the last option, that is execute. The moment I click on execute, you can see here there is a model icon. The model has been generated, and in the model manager, you will be able to see the result. To access the results, all that you need to do is right click on the model nugget and choose the second option, namely browse. This will allow you to browse the contents of the file. As you can see here, this graph tells me the predictor importance. Out of all the variables that I had specified, income of a person is the most important predictor, which can be used to classify a customer as a good credit risk or a bad credit risk. The second variable is credit card. The number of credit cards that a customer uses can also be used to find out whether he is good credit risk or bad credit risk. The third variable is age, and the fourth best predictor is car loans. This is a very, very important chart because this gives me the feature importance. Out of all the variables, the key drivers of credit rating would be income, number of credit cards, age, and car loans. Very interestingly, you can also see the rules in the panel to the left side. What does it say? If the credit cards is less than 5, it implies good, which means that if a customer has less than 5 credit cards, I can call him as a good credit risk. Let me unclick this. Either you can unclick this or you can simply say all. You can see all the rules corresponding to good and bad credit risk is displayed. How do you read this? If the credit cards is 5 or more and the income is high, again, this predicts for a good customer. If the credit cards is 5 or more and the income level is low, this predicts for a bad credit rating. Now, if you look at the heading here, this is for 5 or more credit cards. What happens when a person possesses 5 or more credit cards and the income is medium? I have to look at the next variable, which is age. Age is less than 27.8. So a customer has 5 or more credit cards. He belongs to the medium income class and the age is less than 27 years. He can be called as a bad credit risk. On the other hand, if a person's age is greater than 27 years, which means he is older, then you have to look at the next category, which again is age. If his age is less than 41 years, which means his age is lying between 27 and 41 years, I have to further look at car loans. If a person has none or one car loan, then you can call him as good credit risk. Let me read this again. The number of credit cards is 5 or more. Look at the tree map here. Number of credit cards is 5 or more, and the income is medium. His age is between 27 and 41 years. Very important. His age is between 27 and 41 years. If the car loans that he has is none or one, you can put him in the good credit risk category. On the other hand, If the car loans that he has is more than 2, you have to call him as a bad credit risk. What happens if the age is greater than 41 years? You can call him as a good credit risk. So this is how a C5.0 helps us with not just the decision tree model, it also creates rules. Now you may ask me, why is this useful and how do I use this? Now, many times the consumers of any modeling exercise would be non-statisticians or people who may not be highly interested in the statistical terminologies. Now, that is where these rules help you as well as the end user. You can just develop a if-then rule. You can just create a SQL code or a Python code saying if a person has 5 or more credit cards, belongs to the high income class, then what is the expected category? If he belongs to the low income class, what is the expected category? You can create this kind of a rule and perhaps give this to a front office assistant. He or she will be able to use these rules and score for fresh customers. So when a new customer comes, all that the front office assistant has to do is ask for what's his age, how many credit cards he or she possesses, is he belonging to the low income class or the high or the medium income class, the number of car loans that he or she has. Once you know these details, if the front office assistant is able to run this code, then the model will spit out the prediction saying the first gentleman is a good credit risk, second gentleman is a bad credit risk. Depending on which category that a person belongs to, you can then go ahead and decide whether you should give him a loan or not. You can also interpret the same result by looking at the model viewer. You can see here, this is the dependent variable, which is credit rating. Now, if you look down, credit cards has been identified to be the best predictor. This is the most important variable. In our language, we call the top most node as the parent node. This is just like a person's face, and this vertical line is like his neck. And you can again compare these horizontal lines to a person's hands. So credit rating in the entire variable, in the entire data set, 41% of people are bad credit risks, 58% of people are good credit risks. Now, to identify whether a person belongs to bad or good credit risk, credit cards can be used as the best predictor. If a person has less than 5 credit cards, 87% of them tend to be good credit risk. And there is no other split after this, which means that you can call this as the terminal node. You look to the other node. What do you see here? Credit cards 5 or more. If a person possesses 5 or more credit cards, I can't make a decision right here. I have to look at the next best predictor, which is income, which is divided into high, 5 or more credit cards, and a person belongs to high income class. Majority class is good. So you can go ahead and give him a loan. What happens if a person has 5 or more credit cards and he belongs to the low income class? Look at the majority class here. 90% of them belong to the bad credit risk. I repeat, if a person has 5 or more credit cards and he belongs to the low income class, 90 out of 100 such individuals tend to be high risk or bad risk customers. You want to avoid bad risk customers because they default on the payment. Let's look at the next category, which is medium. If a person has 5 or more credit cards, that is, I'm continuously tracing this path. If a person has 5 or more credit cards and he belongs to the medium income class, 56% of them tend to be bad. But I can't stop here because then I have to look at his age as well. Age is less than 27 years. 82% of them are bad. This is a terminal node, which means I can formulate a rule based on the terminal node. What happens if his age is greater than 27 years and less than 41 years? 50% of them are bad, and approximately 49% of them are good. What if his age is greater than 41 years? Majority of them tend to be in the good credit risk. Either you can look at, oh, I have to further look at car loans as well, because this node is not the terminal node. After age less than 41 years, you have to again look at car loans. That is, either he can have 0 or 1 loan, in which case 66% of them happen to be good. If he has more than 2 car loans, then 52% of them happen to be bad. We usually formulate the rules based on the terminal node. Yes, so this is how a decision tree can be used. Instead of looking at each and every node in the decision tree, you can look at the model, and these rules are generated by IBM Modeler. Now, one thing that you can do is, if you want, you can just copy these rules and paste it in Notepad or any other Word document as well. Let me see if there is anything good in summary. It just gives a high level information about summary. Now, let me click on OK. I was inspecting the output of a C5.0. Now, once you build a model, the next stage is to evaluate the accuracy of the model. Is this model good or bad? Every model is good in pen and paper. When you build a model at an overall level, it may give very, very interesting results. But when you implement it in a production environment, it might not be as good. We want to look at the overall accuracy of the model. Now, to look at the overall accuracy of the model, what I will do is I will have to select the model nugget, click on output, and here you have a node which is called as analysis node. Let me double click on the analysis node and execute this. How do I execute this? Simply right click and say run. You can see here in a span of few seconds, IBM Modeler gives me the output. This is the overall percentage of accuracy. It says correct and wrong. 1,996 records have been correctly identified. So the overall percentage of correct classification is 81%. How many wrong predictions have been made by the model? 468, which means approximately 19% of the customers have been misclassified. What do I mean by misclassify? A customer may be a good credit risk. The C5.0 model has misclassified him as a bad credit risk. Similarly, a person may have been a bad credit risk in the data set. The model has identified him as good. So this is a misclassification rate. If you use this model, 20%, roughly 20% of the individuals can be misclassified. The overall percentage of accuracy is 80%, 81%. Now, this is a good model because 81% is by industry standard definitely a good model. One point that I'd like to draw your attention to is I have not split the data as training and testing. Ideally speaking, you should split the data as training and testing, build the model on the training, and then score on the test and check the test result, which is not the strategy that I have applied here. The second point here is, what is the guarantee that C5.0 is the champion model? At best, I can call this as a baseline model because it is giving me, this is the first try that I have made, and the first try I've got 81%. I have not tried a Bayesian network. I have not tried a shade algorithm. I have not tried any deep learning model. I have not tried a neural network model. I have not tried a support vector machine. There are umpteen number of models which can be used to classify. How do I know that all these models are inferior models as compared to 5.0. Now, let's take a pause. Imagine that you're working in a real-time project. In a typical data science project, you don't have the luxury of experimenting with multiple models because there is a time constraint. There is a deadline within which you are expected to finish the project. So I may not have the time to experiment with multiple models. Then how do I go ahead and propose this model as the champion model? I can only do this if I've tried with other options. This is where, if you want to compare whether the winner model, I can call this as a winner model or the baseline model because this is the one model that I have at this stage. If other models outperform the C5.0, then I can propose the other model, whichever be it, as the champion model. If all other models are inferior to the C5.0 model, then I'll have to go ahead and propose this model itself as the best model. But to try each of these models, you can imagine how much of effort it would take. You have to write the code in Python, you have to write the code in R or any of these other programming languages, and writing the code is not an easy task. It has its own problems. So this is where I'd like to introduce an option which I find very, very useful. It is called as Auto Classifier node. What does this do? It helps us in automating the machine learning workflow, which includes automatic training and tuning of many models. Now, to use the auto classifier node, what I'll have to do is click on modeling. And here, when I choose the option all, earlier I had chosen classification. When you click on modeling, you can see 5 different items here: all, analytics server, classification, association, and segmentation. If the machine learning problem in hand is association, let us say you want to do market basket analysis, please click on association. It displays all the nodes related to association. If you're doing unsupervised learning, you can choose segmentation. Here, since I'm doing the auto ML, I can choose the option all. You can see here, the very first option here is auto classifier. If I look at some of the models here, you can look at TCM, random tree, cart model, decision list. There are numerous models. You don't have sufficient time to try all these models, and this is the big problem. Here is where this particular node, which is called as auto classifier, comes to my rescue. IBM Modeler gives me a quick description. What does it say? It constructs and compares predictive models with binary and set outcomes. When I say set, it is just a categorical variable. So let me try my luck with an auto classifier node. You can also try this option with H2O. H2O also has a good auto ML node, which you can use to automate machine learning. Let me just arrange some of these nodes so that you can just see it clearly. Earlier, I had built the C5.0 model. This is my baseline model. So let me just right click and say, this is the baseline model. I'm just commenting this out so that it's easy for the viewers to see this. This is the baseline model that I had, which is the C5.0. And this is giving me an accuracy of 81%. The model that I have used is what's called as C5.0. Now, let me establish a connection between the type node and auto classifier. To just summarize, I imported the data set, I accessed the variables, I displayed the contents, then I went on to build a C5.0 I was able to interpret the rules as well as the decision tree. Once I executed, I got the model nugget, and then I checked the results. Now I am running multiple models, and I'm going to compare the rest of the models with the baseline model of C5.0. Let me open up this node. You can see here, fields allows you to specify the fields. I'll go to model here. You can either work on the partition data or the entire data. How do you want to rank the models? There are 5 options here. Either you can choose overall accuracy, or the second option here that you have is AUC, or the area under the curve. By plotting the ROC curve, we will be able to pull out the area under the curve. You also have the profit metric, the lift, and the number of fields. I will choose overall accuracy, which means at the back end, IBM modeler will run 14 different models, and whichever will give me the highest accuracy, it will choose that as the champion model. If you know the cost and the revenue, you can specify the cost and the revenue here as well. Here, for a flag target, the default cost that is considered is 5, and the default revenue that is considered is 5. But this is entirely under your control. For your business, what is the cost and revenue can be specified here. I'm not going to tinker with these options. Let me choose the option expert. You can see here the list of models that IBM modeler would run at the backend. It would anyway run a C5.0, logistic regression it is going to run, decision list, Bayesian network, discriminant analysis. I can tick mark this as well because this is KNN algorithm, linear support vector machine, random trees. I also have a SVM method, which is a non-linear version of support vector machine. Then you have other algorithms like tree, shade, quest, cart, and neural network model. Now, all these are the models that IBM modeler will run at the backend. And based on the overall accuracy of each of these models, it will propose the champion model. And this champion model, I can share with my client and say, boss, I have run these 14 models. Now it is up to you to choose which model you want to go ahead with. Let me draw your attention once again. Here, I'm choosing the option rank models by overall accuracy. You can choose any of these 5 options. So fingers crossed, I'm hoping that I get a good model, a model which gives me a better accuracy than C5.0. Now we have to have a bit of patience because at the back end, what IBM modeler is doing is that it is running multiple models. And if the data set is really, really large, it might take a long time. You can see here, there are 2 nuggets. The first nugget is C5.0. This is the latest nugget. Let me right click and choose the option browse. Wow. You can see here, these are the 3 best models that IBM modeler is proposing. The first one is what is called as KNN algorithm. Why is this considered as the best model? Please look at the AUC. AUC is 92.8, approximately 90%. If you want to look at the overall accuracy, the overall accuracy here is 84%, which is 3% higher than my baseline model, namely C5.0. Now, I know that running a KNN algorithm would give me the best results. If overall accuracy is what you're looking at, you can go with this particular model. The second best model is what is called as a Bayesian model, which is giving me an accuracy of 81%, which is more or less the same as a C5.0 model. Look at, this is 3% lesser than my champion model, namely KNN algorithm. Look at the AUC curve, it is 0.3 units lesser. The last model is a logistic regression model, which is again somewhere around 81%, and the AUC is 0.89. So You can now confidently go ahead and say, for the credit risk problem in this data set, the champion model that we can declare is the KNN algorithm. Imagine if you had to experiment with multiple algorithms using a Python code or R, the amount of time that you take, the amount of resources you would need, that happens in a jiffy, in a span of a few seconds. We've been able to run 14 different algorithms, and we are able to decide that KNN is the champion algorithm. It also reports the lift. A lift for the top 30% of the cases, it is 1.6. Any number greater than 1, you can always be happy. The profit that is generated using the KNN algorithm is 5,351 units, which is greater than the other two models. So this is how we can evaluate which is the best model for our data set. So with this, I've come to the end of today's presentation. I hope you have liked today's presentation. In case you have liked today's presentation, I request you to hit the like button. But before we close, you can also use the graphs here. So the predictor importance and the graphs are being shown. We have already seen the predictor importance, so I will not again explain this. So thank you very much for watching today's video. I request you to subscribe to my channel and hit the like button. Thank you very much. Have a great day.